When certain atoms called bosons have even numbers of protons and neutrons, something incredible happens when we cool them near absolute zero. Take deuterium, for example. At ultra-low temperatures, all the atoms merge into a single Bose-Einstein condensate, one giant quantum wave acting as a single particle. In this state, normal forces like the strong and electromagnetic interactions are suppressed. The atoms lose their boundaries and can fuse together cold, forming one unified quantum object. Then, when the condensate is compressed and heated, coherence breaks and the nuclei ignite, releasing fusion energy. It's fusion through cooling for unity and heating for ignition, a new vision of quantum fusion powered by Bose-Einstein.
For centuries, physics has treated the speed of light as an unbreakable barrier. But what if nature itself has already shown otherwise? In Superluminal Particle Accelerator reactor design, Rosario Elenes Cazares presents a groundbreaking framework that unites observational astronomy, laboratory quantum experiments, and advanced engineering design. Drawing on cometary data revealing natural Bose-Einstein condensates, achieving up to 7% of the speed of light without engines, far surpassing conventional spacecraft, and combining it with laboratory-validated scaling laws. This book introduces the Superluminal Velocity Specification, a practical formula for building reactors that harness quantum coherence to reach and control superluminal speeds. How these reactors differ from classical accelerators, unlike traditional accelerators such as the Large Hadron Collider, which use superconducting materials mainly for efficiency, these systems are fundamentally quantum coherent reactors. Particles are confined within a BEC chamber, and the reactor functions as a unified superconductive circuit. Superconductivity arises from the reactor itself, not from external energy input, transforming the design from a power-driven accelerator into a persistent current quantum system. Cooling is the driver of velocity in these reactors. Cooling, not applied force, drives motion. Electrons near 99.999% of the speed of light achieve this velocity, not through added energy, but by reduction of thermal resistance. As temperature approaches absolute zero, quantum coherence emerges, setting the lower bound of motion and allowing near-light and superluminal speeds to arise from lossless quantum order. Two sides of the same coin here. Space-time warping is quantum coherence. Geometry cannot be observed without collapsing the system, yet it dictates particle motion. In relativity, geometry tells matter how to move. In superconductivity, quantum coherence is the geometry. Superluminal speeds occur when spacetime itself becomes superconductive, fully consistent with Einstein's relativity and Alcubierre's warp drive framework, where warped spacetime allows faster than light motion without violating local physics. Electrons move not by applied force, but because the self-generated geometry guides them. Cooling preserves coherence, enabling the reactor to create the space-time structure needed for motion, linking quantum behavior directly to observed superluminal velocities. Bosons, as the fabric of space-time all forces, electromagnetic, strong, and weak, are mediated by bosons. When bosonic atoms are cooled into a Bose-Einstein condensate, they form a coherent ground state that defines motion. In superconducting circuits, this coherent bosonic field generates the geometric order that guides electrons even with the battery off. Superconductivity emerges because the warped bosonic geometry itself sustains motion, showing that space-time curvature and force mediation are inseparable consequences of bosonic coherence. Because the geometry is fully coherent and self-generated, superluminal motion is naturally permitted without violating relativistic limits. The ultimate warping of spacetime, the most extreme warping, occurs in black holes, where gravity compresses stellar gas to extraordinary densities. As a star collapses, gravity-assisted cooling allows bosonic atoms in the gas to radiate energy while density increases. This combination of cooling and compression enables the bosons to condense into a coherent Bose-Einstein state. The resulting BEC forms the ultimate coherent geometry, creating the profound space-time curvature observed as a black hole. Black holes, therefore, can be understood as nature's ultimate BEC reactors, demonstrating on the largest scale how bosonic coherence shapes motion, forces, and the fabric of space-time.
The only true warp drive is the Bose-Einstein condensate warp drive. In empty space, its superconducting quantum state allows motion by interacting with electromagnetic resistance, moving without any battery fuel power source. in an atmosphere like on Earth, the same BEC superfluidity provides unmatched aerodynamic efficiency, reducing drag and maintaining precise control. Unlike algebraic bubbles or other theoretical ideas, these achieve true warp motion because the state of matter itself enables it. All other warp drive concepts are not real.
This explains how a Bose-Einstein condensate behaves as a single quantum object. When it stays below its critical velocity, the entire condensate acts in perfect unity. Individual BC chips, once connected and given the same phase, merge into one quantum object no matter their size. Through careful cooling, compression, rotation, and time, bulk BC can be created at the densities needed for specific critical velocities. Because of its extreme compressibility, those densities allow the BC to maintain any required temperature. Below the critical velocity, it shows superfluidity and even superconductivity, producing highly efficient quantum aerodynamics. This makes it possible to build large quantum objects from smaller ones through a single shared phase.
Imagine dozens of Bose-Einstein condensate chips, each holding atoms merged into a single quantum wave. When their phases line up, they don't just sit side by side, they fuse into one extended condensate, shaping a continuous geometry of superfluid matter. The problem is that real life is noisy. Tiny magnetic fluctuations, temperature changes, and mechanical vibrations constantly try to scramble the phases and break the global structure apart. This is where on-chip sensors and AI-driven accelerators come in. They monitor the phase of every cluster in real time, detect drift within milliseconds, and adjust local fields to pull each region back into coherence. The AI continuously solves the optimal correction pattern so the entire array maintains a single, unified quantum phase. To make this even more precise, the global 3D shape of the condensate can be unfolded into a 2D layout, just like flattening a box into a net. That 2D map can be imported as an image, letting the AI track distortions, modulate phases across the array, and apply cleaner, more coordinated corrections.
Einstein's relativity sets a universal speed limit. Nothing with mass can reach light speed, because as velocity rises, momentum increases energy, and energy increases effective mass. The faster you go, the heavier you become, demanding infinite energy to reach C. But a Bose-Einstein condensate breaks from that classical chain. When matter is cooled near absolute zero, particles merge into a single quantum wave, a superfluid shell that can't transfer momentum the way normal matter does. It moves without friction, without classical drag, and its collective state keeps energy and velocity decoupled. In such a form, a ship surrounded by this condensate could glide through air or vacuum with almost no resistance. Yet, the instant you try to measure or interact with its geometry, the condensate collapses, returning to Einstein's world, where speed, mass, and energy are forever linked.
Imagine an electrical transformer. But instead of electrons, it channels the collective wave of a Bose-Einstein condensate. This quantum wave becomes the conductor, guiding gravity itself. By shaping the condensate's density, we can steer the flow of space-time, amplifying positive gravity here, negative gravity there. The BEC acts as both wire and core, directing the invisible current of gravity like electricity in a circuit. Stabilized at room temperature, the condensate's coherence keeps the gravitational field steady, controllable, and tunable. In essence, the BBA's transformer converts a quantum wave into a gravitational current, letting us guide the pull and push of gravity itself. A black hole in this model is a Bose-Einstein condensate state of matter formed when a bosonic gas collapses and cools under extreme gravity. In this condensate, the matter becomes simultaneously superfluid and superconducting, meaning it has zero viscosity and zero electrical resistance. At the event horizon, this condensate forms a superfluid and superconducting surface. Because this surface has zero friction and zero resistance, nothing crossing it can generate the reaction force needed to move back outward. Everything outside the black hole exists in a higher energy configuration relative to the condensate's ground state. As an object approaches the horizon, the bosonic potential difference forces it toward that lower ground state. And this is the crucial point, because the event horizon itself is a perfectly frictionless, perfectly conducting superfluid surface. There is no way for anything to push against it or create a disturbance that would allow climbing back up the bosonic potential difference. This makes escape physically impossible. The horizon is a one-way surface defined by the Bose-Einstein condensate state of the black hole itself. The cloud of a black hole is the BEC decoherence transitioning back to a gas where information is conserved.
Wormholes are not just science fiction. They are quantum phenomena arising from the superconductive, superfluid nature of spacetime itself. Spacetime may be a Bose-Einstein condensate, a cold, coherent quantum gas spread across the universe. In the frozen voids between stars, this gas becomes both a superfluid and a superconductor, flowing without resistance, shaping gravity, light, and expansion. Einstein described geometry. Alcubierre imagined warp bubbles. But the real universe may be quantum, superconductive, and fluid. As this condensate expands, its dual properties let space stretch faster than light, driven by the extreme cold of interstellar gas. From the same quantum fabric, wormholes can form natural connections through space-time itself. The universe expands because it flows a Bose-Einstein superconductive superfluid of reality.